push these current values further down my little list. I made a quick guess of what the DC amps were doing based on a formula that I created. All right, gentlemen, today I'm going to walk you through this controller. It's an APT 96800. It's the same model, ironically, that their APT 9611000 controller is based on, so you can program it higher than the 800 amp phase amp would suggest. I've been actually quite impressed with this. It takes a lot of power, it doesn't overheat, and it runs really smooth with a lot of customization possible to perform. I did get a little bit discouraged initially because I did not realize how well the documentation was laid out and what resources were available for figuring it out. And so I will walk you guys through what this comes with, how you get what you need to, have as resources, what you need to know prior to getting into it, and then walking through each of the parameters line by line, how to make sense of the program once we're into it. So stay tuned and we'll go in a deep dive. So it comes with a little plate that tells you some of the specifications: 800 phase amps, 100 amps continuous rating, which gives it about a 12,000 watt output continuous. I found that those are underestimates across the board of what this can handle. It can go up to, the normal 120 volts that any 96 volt controller is rated to do. So if you're like, oh, mine peaks at 116, I can't use 96 volts. That's just the nominal rating. This is 300 battery amp capable is what it claims. I have verified currents flowing through my wires that were up to 450 amps. And I anticipate I can get a little bit higher than that as I start diving further into, pulling power from this controller. And after doing multiple pulls at that level, you can stop, you can pull over, you can feel the side on the heat sink of this. And it is, I would say, operating temperature. It is by no stretch hot, dangerously warm. It feels warmer than ambient. I would say the temperature may be 120 Fahrenheit. So I've been pleased with this unit being, it's underrated. It's bulletproof from my experience with it. It's also highly customizable, and it comes to a certain extent pre-programmed. If you get it as a kit, they do pre-program it to certain specifications that are not as high as I would like them to be, but fairly reasonable. I mean, you plug it in, turn the throttle, and it will already run. It's been tuned to run correctly based on the motor that you purchased it with. So this one did come as a kit, but I reprogrammed almost all the parameters, tweaked them here and there, just to make sure that it fit my liking and my desire. So when I got this controller and motor kit, I asked them for the application for programming, some of the resources that might come with it, and they sent me a link to a Dropbox that they created, and this is that Dropbox. And they shared it with me. I don't think I could forward this to anybody and have it work for them. But the first thing I did was download the whole thing, the entire content, and I put it in a folder called the Ducat E. There are other things in here like designs for batteries and a modified tuning sheet, things of that sort. I had to just extract the zipped folder that showed up once I downloaded this packet. There are a lot of things in here that were useful, but it required me kind of digging in to figure out what I needed to use. I put a separate window with all of the things that were useful to me. I'm gonna walk you through what those are. So this is the first file that I found super useful for getting into the program. It's the preparation for debug kit system. And some of the stuff just walks you through how to connect to it. Obviously there's a port with a cable that they send. But once you're into that stage, you'll head to the folder that was shared to you by the seller that has the software and everything zipped up. So you'll grab that, you'll unzip it, and then you'll dig through this program. Let me show you so you go to software, which is one of the folders. PC software registered, just like they shared. And then whichever your system is, you'll click on the correct one. I did 64 because that was my system. Once you hover over the one that you want, you right click on it and are able to then run as administrator. Once you've done that, it allows you to run, install, and start that software up. A little bit counterintuitive because you can't just click on something and have it work. I tried doing all kinds of roundabout ways, not realizing I just had to find that guide, right click it, and run it as an administrator. Once you're in it, it'll throw you this, just a blank display. And this is where it gets a little bit weird. It won't communicate by default. You turn the controller on, so you gotta power the controller on. It'll still show this. It'll show state fault, and it's kind of showing you this to explain that that's the case. What you'll do is you go to options, comm settings, and then you pick the right port for what it is. There are 9 port options they provide. Each USB port is assigned its own comm. So you could really just click through it, try each one of them out, see if it works. This port is COM 5 on mine. This port is COM 8. So depending on which one you plug it into, it's different. What you can do, let me turn it on and show you, is you can actually go to Device Manager. And if you go to ports, COM, and whatever else, it is USB serial COM port, and it says it's in COM 5. So on my software, once I open this up, so what I did is when I extracted it, it saved it to my program files. I just went ahead and brought the software and put the application back in my main folder here. So it brings up that page. Until I set it to COM 5, port number 5, it won't show up my parameters. Now, brings up my bike parameters, my controller parameters. You can use this as real-time. The left side is basically a real-time readout. It shows you what mode you're in, mode 4. So for some of the programming functions, that's helpful. Mine's permanently in mode 4. It shows me RPM, which I use to calibrate the speedometer based on the diameter and circumference of the wheel. So this was helpful to me for real-time readouts. The part that matters for programming is all these options here. All you'll ever do if you want to change settings is go into each of these functions. And when I go through the parameters, these are the ones I'm going to go through. Some of these other documents here were helpful. It showed you how to change acceleration, deceleration, things of that sort. This was a file that came with it. It basically is a crash course to simple tuning. I won't go over that. That's included in your folder. I will encourage you to explore everything in this folder that you unzip though, because there are plenty of really useful features there. The best resource for this purpose is the parameter descriptions of in-wheel motor applications. So they have certain things that are locked, unavailable, or in some cases programmed and then are best to leave alone as a result of the motor type. This actually did not come in the folder that was shared, that I found and have saved to my own folder because it was immensely beneficial. It walks through line by line. So if you guys need this, can't find this, you could really just search parameter description of in-wheel motor applications or user manual of parameter settings, APT. But it's immensely helpful, and it shows you interface, it shows you where things are, each of the settings. Remember I told you on this window it goes basic, reference, motor, control, torque. Each one of these brings up a dialog box. And so this is, I'll just run you through some of the highlights on here. There's certain ones of these that aren't necessary to really do a whole lot with. And then there are others that are, very beneficial to change. So max motor current range is 0 to 600 for the APT 96-600. For the APT 96-800, that goes up to 1,000. I've set mine to that value. And then it shows you, you can break this down further into subsections, which is what I was talking about. That's what the RPM function is useful for. I think I set mine, let me look, higher, strategically higher than what it really is. I set it to 2,300 because I was basically deceiving the motor into thinking that it was at a higher percentage of its max RPM than it really was, or sorry, a lower percentage, so that it fed more current to the motor than it otherwise would. So I really was trying to juice what I could out of that controller. And I also set the acceleration value higher than it otherwise would have been. They recommend 1,500 here, or you can turn that higher. In some cases, 3,500 is recommended. I went a little higher than that. I'm gonna try playing with this more, possibly turn that up a little bit. Let's say hypothetically I wanted to turn it up. I could turn that to 7 and just click right. And it would real time adjust that. It is now live. No needing to reset the controller. It's already live on that controller. So those two are pretty important. Some of them are locked or not really to be worried about. Not available for in-wheel motor, which is what I'm using, so I'm not gonna be diving into those. This is that acceleration value I just set to 7,000. I might turn it higher, we'll see. And then the backwards ones are really not important because you just barely turn the throttle when you're going in reverse. You'll never use those. So on that first screen, the ones that are meaningful are the first two, overall amperage. This is your phase current limit, max speed of the motor, and then really The acceleration value is one that I would change. So reference is the next dialog box that pops up. You just set your over voltage limit. This is the max voltage of your battery. I just put 120 because it's not stopping anything. I have a high voltage cutoff on my BMS. If you're not charging through a BMS, this is super important to set, but if you're not charging through a BMS, you are either really closely watching your cells or you are really messing up. This is just what it will begin working again once it drops down to. So if it goes into the shut-off mode, it drops back down to that. What your low voltage cutoff is, and then again what it has to recover to before it turns back on. So if you say you run it too low, and then it has to sit for a second to recover back to this value before it works again. So we'll look at their description as we go through some of these. Some of them become very specific. You can actually shut your regen function down so it does not work past a certain voltage. So let's say your battery pack's max voltage is 116 and you drive out of your garage and the first thing you do in the mornings is go down a steep hill and you don't want to regen past your battery's peak voltage. You can turn it so regen does not work past a certain voltage. That's what this parameter is, highest voltage for regen. Again, some of these not available for in-wheel motors, so things I did not use. Backward just means reverse. So anything that's backward related, you do not need to program because your performance in reverse, as long as it is able to pull you backwards out of a sloped parking space, it's done its job. I wouldn't worry about at all what the torque backward is unless you've got to back out of a massively inclined parking space, in which case park somewhere else because other issues would arise. If you're at higher than or less than a certain voltage, you can reduce the battery output. Realistically, your battery, based on the parameters above, should never get outside of their acceptable ranges, so you shouldn't need to set these. I did not set mine past what they were already by default. So certain elements of these are locked. These next ones about the start stability ones here, you're not able to change. Those are hard programmed. Let me show you which ones I'm talking about here. That's this. These ones are locked. And then if you're using eco mode, you can set some of those same parameters separately. Motor parameters should come correct by default. I did not change mine because they were all correct, but the number of motor pairs or motor pull pairs, where the Hall sensor degree angles are, and see these are normally locked, it shows. High temperature cutoff, that's all set by default. If you want yours to be higher or lower for either better safety or more abuse, you can change that. No need to remap. It says do not modify. So literally this category, if it came as a kit, you won't need to touch. If it did not, change your number of pull pairs, change your Hall angles, and then realistically just make sure the rest is reasonable and you should be good to go. Protection, this is a very important category. This is at what levels your controller provides power to the motor. I didn't change the heavy load timeout, that's actually phased out. Motor lock, I did not connect that wire even. But these are locked parameters. If you end up exceeding certain parameters for a certain amount of time, it'll end up shutting you down, basically. And then these are when it's considered a heavy load, quote unquote. So that's applying to this here, right? And then motor lock, current percentage, shows the same thing after a certain amount of seconds. These are the parameters that control this. I didn't change mine. So this is where it gives you the hard shutdown. You can either turn it lower for more safety or higher for more abuse, again. And then when it'll turn back on after it shuts down, right? This is where it gets really specific. So this is where you're setting each of the 13, so you'll notice there are 13 dots here, but this is basically splitting your RPM range into 13 groups. It tells you how much phase current you want at each of these RPM ranges. Obviously your phase current decreases as time goes on, as you ramp the motor to its running RPM, to its operating RPM. But the battery current tends to come up and then levels off as your motor's not able to handle it past a certain point. Or as your controller, I guess, really can't handle it past a certain point. So my goal was to turn this up as high as I could without running into heat/safety issues. As it turns out, that controller is bulletproof, and I was able to turn it as high as I possibly could. So what I did was I broke I had I guess a separate Excel. Let me pull that up. I pulled over the Excel spreadsheet they shared with the values they shared at the RPMs that they shared. Obviously, that motor RPM is higher than my motor's max RPM. The max RPM is 1600 at full battery voltage. So instead of having it be 1600, past a certain point in my protection category, it starts to, I turned it up, right? So I have 1000 phase amps And then I just turn these up. So yeah, it ramps down, but not very fast. And at 4, which 4 is still a good RPM, probably be at like 600 RPM. And so we're at 50 miles an hour, let's say. So it's still pulling a good amount of phase current at 50 miles an hour. But what happens is once you get to step number 7, it goes into hard protect mode. You cannot turn this above 255. And I don't know why it makes it so hard. It's got, I mean, perhaps it's because of MOSFET ability to what it can handle, things of that sort. But I have not run into an issue where I feel as though the controller is struggling. And so what I did, instead of, I couldn't turn those numbers up past 255, and I wanted to pull more than 255 battery amps, and I haven't entered our flux weakening stages yet. And so I wouldn't be running higher battery amps than phase amps. It wouldn't have inverted at this point. And so because I knew that number 7 was probably only 70 miles an hour, and at that point I lose my battery current, what I did is I told my controller that my motor runs at a higher RPM than it actually does. So I put the max speed at 2300 RPM. What that tells me then is if I break that into 13 categories, I'm going to be at 1150, which is probably 80 miles an hour before it starts to ramp me down in my current. So that was kind of something that I did to trick the motor. Basically my goal was to have it outputting as much power as it could handle, and it has not ever run to a point where it shuts down or has anything of that sort that has caused me concern. So back to the spreadsheet, what I did was I just ramped it up according to some calculations I did, 800 amps, and then I was like, well, let's just go a little higher. So I did 1,000 amps, and then the actual RPM I saw at about 106 volts, 107 volts. And then I finally landed on where I wanted to be. And so I created this sheet of values I wanted to enter, recognizing past 7. These numbers all defaulted down to 255. I could not attain those, and so I just ramped the RPM up a little higher so I could push these current values further down my little list. I made a quick guess of what the DC amps were doing based on a formula that I created, and it ended up getting to 400 was the estimate. I ended up seeing higher than that. I saw about 450. I could probably get it to 500 if I really program it a little higher. That controller puts out a lot of power. That's 50,000 watts or more. And then there's just massive losses past a certain point, right? You're losing efficiency by cranking it that high. But my goal was to see what that motor could do. It never gets terribly warm. The phase wires get a little bit noticeably warm. They're a long run of 6-gauge wire, so I wasn't terribly pleased with the sizing on that. It would have been much better had it been 2-gauge, especially considering it's supposed to be a 12,000 watt motor with a peak of 28 to 31,000 watts. You'd think they would give you 2-gauge wires, but maybe I'm hoping for more than is feasible. So what I did for my protection parameters, going back to this list here, is I bumped mine up way higher than what it was allowing me to. And notice, I'm surprised that the 600 phase amp, you can see why dropping it to 255 frustrated me. So I wasn't really pleased with that element of it, so I did just artificially allow that to be boosted higher. This allows you to customize the throttle. You can say how much throttle is being applied at the midpoint. You can define what the midpoint is, what the high point and the low point voltage-wise, which allows you to, tell you at what point it engages, at what point it's at peak, and what point the middle is. So there's that description of the throttle, the mid, the low, the high, what voltage is, right? And that depends on what throttle you use. It's got some more backwards reference, so you can do the same thing where you define the current range. This again is useless for reverse. Don't bother programming reverse. As long as reverse works, you don't need to be powerful. That's not the point of reverse. And then flux weakening I did not use because our top speed is well sufficient. The top speed at peak voltage is 115 miles per hour on a stand, meaning you let the motor just spin up to its RPM of the motor based on the voltage that the battery is feeding it, or the controller is feeding it, I guess, because that's a big inverter. So no need for flux weakening, but had you need to do flux weakening, I think you'd change 6 and 7, and it allows you to imprint flux weakening. There was a separate file that showed you how to do flux weakening. So tune the flux reference as following figure, meaning you didn't get to the speed you wanted to at your max RPM, So you can turn that up to be able to invert your battery and phase amps effectively, so you are forcing a higher speed than the voltage should allow you to do by basically increasing the voltage from the controller, is kind of the way that works. So it walks you through that a little bit. This is one of the references that they did send. And then current DC gain, current DC2, you shouldn't really need to change those. You can change the pulse width if your battery's having issues with keeping up with the pulses that it's requesting, things like that. I didn't need to change mine. My battery's able to handle it either way as it came stock. I don't know what the range is on this one, but if you have issues with cutouts, things of that sort, pulse width might be helpful for you. That category there, the current DC calibration, this is mostly useful for changing the direction of your motor rotation, assuming it spins the wrong way. And they have a great resource that walks you through that. Mode set, this is important. This is the current DC in mode 4, which is where mine permanently is set. You could actually have weaker modes, mode 1, 2, 3, or 4, which have less, I guess 5 as well, but the current in what mode you are in. I just kept mine in mode 4. I didn't change, so this is if you want slower speed modes, higher speed modes, and you wire that into your throttle grip control. I just have mine set at the max speed, and I have the current for that mode set to, I think, 1,000. I think it locks you at current DC of 255. Let me try going to 500. Let's see if that accepts that. It'll say that it does. But let's see if when I open it up, it stays there. That's as high as it can go. Let's see if mode 5 can go higher. Nope. So the most useful things in this bottom category is going to be making sure your current is high enough, making sure your RPM matches what you would want it to be. If you do use boost function, you can use that, but also setting your regen parameters to match. That's all controlled here. There's a separate resource I sent for how to activate regen. There's also a Derate settings, which if you want to use eco mode, you can set up the reference again for eco mode, to each of those values. Derate is only useful if you have a eco mode. So good documentation. I wish this document was included in that folder they send out, but I would encourage you, when you do unzip your folder, explore all of these really thoroughly. There are a lot of resources buried within some of these folders. And I pulled some of the highlights out onto my bar up here. Some resources help you with wiring it up, but the majority of them are focused on understanding how to use the software. And that's where I had most of my struggles until I found the resource that helped me with how to run as an administrator and how to find the right COM port. And then this one helped me a lot with each of the parameters for how to do those programming features. So I did change some of my settings in the process of this. I'm going to take it for a quick spin, see if any of the things that I adjusted, this acceleration here, I'll see if this was helpful, other things of that sort. So I'll take it for a spin, and then you'll see the outcome of this when we get the final specs, top speed, acceleration, all those types of runs that we do, and post that up in the next large video on the Engines channel. But ultimately, I've been impressed with the controller. It feeds plenty of power to the motor. It seems as though, and I'm going to find out for sure if this is the case, that the part that is holding us back from getting more juice is not the controller, it is the motor, which is just wound for a really high top speed, which is nice, because a high top speed is nice. If I had to choose between 0 to 60 in 2 seconds and a top speed of 60, or 0 to 60 in 6 seconds and a top speed of 110, I'd be torn between which one I would want. And so I understand, and the 2 seconds, 0 to 60 was an exaggeration. You probably wouldn't get higher than 3.5, maybe on a good day on a different winding. But I feel like they made a good call by having it be a higher top speed, because then you're not stressing it out, running it at 75 on the freeway. That's normal operation for that wheel. So anyway, I've been very pleased with how this is all tuning out, but even more than that, I would say the controller has been the part that has impressed me beyond what the specs showed that it should. It was underrated, and how often are things that you find underrated? It's a pretty rare occurrence. So I'm gonna run this, we're gonna see what the outcome is, and I'll let you guys know where we sit. So catch you next time.